and the children get to know exactly what those numbers are without having to add the dots up. And we use them for all sorts of different things: multiplication, division, addition, subtraction, fractions, all sorts of things. And then there's a whole array of equipment that we use throughout the year to support our learning in different topics. So we've got 100 squares, little clocks, cubes, balance scales, lots of different manipulatives there for mathematics. So with the way we teach maths now, we've actually changed from what maybe you or I used to do at learning maths in school. So our new way of thinking is that the whole class moves through the content at the same time and at the same pace. So everybody's working on the same concept in mathematics, and we're all moving through at hopefully the same pace. Obviously, some children grasp things quicker than other children. So we don't hold those children back. Those children, we try to teach them to become mastery in that skill. So we deepen their learning, maybe through more reasoning or more problem-solving questions, while some children might still be working on that fluency, learning just how to understand what that concept's asking. Other children will be solving problems in there. So each topic that we study is studied in depth. So they might be working on place value or addition or subtraction for like a good 6 to 8 weeks, because we believe that we don't move on to the next stage until those children have really grasped that learning in that topic. So if they were doing, you know, say subtraction one day, addition the next day, then we're moving to shape on a Friday, then the children lose concept of where we are in that topic. So we all move together on the same subject, all moving through the same teaching, but we just have to sometimes deepen some children's knowledge if they've got the concepts quickly, support children maybe through more manipulative with the concrete apparatus who are maybe struggling a bit with those concepts. Students are given a lot of time to think deeply. We do lots of talking about mathematics to get a real understanding of what's going on. And this helps us to get to lead to greater progress, because it's ensuring that those students are secure in their understanding and even their talking about what they are doing. And this enables us to not have to revisit lots of topics once they've been covered in depth. We can move on to another topic, start our new learning. So that's how we work through the curriculum in Year 2. Usually children are put into different groups in mathematics, and in the past often you'd have your children who've really grasped it, your more able group who are racing through curriculum, having lots of ideas, got harder numbers, and then you've got that little set who might struggle with maths and they feel that they're struggling with maths and they're on lower numbers, and we have that divide in the class. We no longer teach maths like that. Children are encouraged to work together and they're encouraged to work on the same concept together. So we don't have that feeling of I can't do maths, I find maths hard, I have to do easy work. Those children are working through on the same concept, but they might be supported more with the concrete apparatus, or other children likewise might be gaining a greater depth with their challenge and their problem solving and reasoning activities that they're given. Sometimes we even get those children who've got the concept really well to teach those who are learning and struggling with it a little bit, because they're then talking about what they've learned as well. Okay. So here's a little insight into what the curriculum looks like for Year 2. So we're currently working within this addition and subtraction unit. So as you can see, it's 5 weeks long. So the children are gaining a deeper knowledge and understanding of that addition and subtraction over that longer period of time. And then we'll move on to money, which will apply our addition and subtraction and what we've learned before then beginning multiplication and division. So you can see there those longer units of work, so the children can gain that greater depth of knowledge on that one topic that they're studying before they move on. Okay, looking back to that, what I mentioned at the beginning, where we look at that varied fluency and the reasoning and the problem solving. Here's just an example of what that varied fluency might look like. So the children here are trying to work out 17 plus 5. So one way we could teach them to do that is to begin at 17 and count on 5. So that's one way of, we want those children to fluently be able to do that procedure. Put the big number in your head and count on 5 more. But we also expose them to using their number bonds to solve those sort of questions as well. So we could say that we'll put 17, we'll start at 17, but actually we're going to split this 5, we're going to partition it into 3 and 2. So they will already have done that because we'll have looked at that in our place value unit at the very beginning. And instead of adding the 5 on in jumps of 1, we will use our number bonds to 20. So the children would notice that 17 and 3 would take them to 20, and then we'd need to add 2 more on to get to 22. Now, at the moment, we've been looking at that concept, and the children do find that quite hard, but we expose them to that daily. So whenever we're faced with a question similar to 17 plus 5, some children will be using it in jumps of 1, but we expose them that another way we can do it is using those number bonds, so that they're constantly being asked to talk about and reason with how they're working out the answer to that one. So that's looking at varied fluency. We wouldn't just give them a whole set of questions and ask them to put the big number in the head and count on. We will explore different ways of doing that. Likewise, that similar concept might be put into a reasoning question where we ask the children, is this concept, does it always happen? Does it sometimes happen, or does it never happen? And we're asking them to explain their answer. And this is another area of their learning that they often find a challenge. They often say, well, I just know it is, I know that's the answer. But we're asking them to explain mathematically how we work out a question. And then another example, like I mentioned earlier, how we find listing all those possibilities. How many different ways can we put those 3-digit cards into this calculation? Can you find me all the possibilities? So the children, we're deepening that knowledge of working out what a 2-digit number and a 1-digit number is, but we're looking for all those possibilities. So that deepens their knowledge and enables them to problem solve, as opposed to just on the previous page putting that number in your head and adding on. So you can see how we've gone through that. We've taught them that concept of working calculations out. Now we're putting it into those problems. So here is a pictorial way that we teach the children to help them to work out some calculations. So this is called a part-whole model. So all the children in year 2 will have been exposed to this in year 1. I think even in reception, it's introduced as well. So it's the idea that a whole number can be put into this model. So this becomes the whole, and from that whole, we can partition that number into different parts. So in this model, 37 has been partitioned into 30, this is 3 sticks of 10, and 7 ones. So that is the 2 parts that together make this whole. So then we start to say to the children, we'll do it with other numbers. So what about 45? So that'll be 4 10s, 5 1s, 40, and 5 makes 45. But then we start to explore, well, is that all the ways we can partition this number? And the children then begin to realise that one of these 10s could be moved over into this part, and 37 could become 20 plus 17. And then they quickly realise, well, actually, we could leave a 10 in here and it would be 10 and 27. So then we're finding all those possibilities of partitioning 37. And then some children say, well, actually, we could have, I know 4 numbers that make 37. So they begin to add other branches onto this part-whole model. Okay, and then this part-whole model can then help us to see the relationship, the inverse relationship with subtraction as well. So that 37 take away 30 would become 7, or 37 take away 7 would become 30. So we explore this in lots of different ways in place value and also in our addition and subtraction unit as well. And the children become very good at using these to help them support their calculations. And then they can record them in a more abstract way, which would be 37 equals 30 plus 7 or 20 plus 17. And we'll give them the manipulatives in the class. So we'll give them the 10s and the 1s to use on the table with one of these models. So they're actually physically making those numbers and then pictorially drawing them and then in an abstract way recording their calculations as well. So that's how we can dig deeper into knowing what these calculations actually mean. And the children then can find all the different calculations in that fact family as well. Okay, here's another pictorial model that we often use as well. This is called a bar model. So again, the whole is on the top, the biggest bar. So there's that 37. And then we've partitioned that into 30 plus 7. So again, the children can see pictorially that number 37 can be partitioned that way. And likewise, 37, if we take away that 30, we're left with 7. So that's another way we often use. And certainly through November, we do what's called a bar-vember. So every day there's a bar model calculation problem on the board, and we explore using, by drawing one of these, the children use their whiteboards to explore how to answer the calculation in the problem. Here it can be used for multiplication. So we've got 3 lots of 10 make 30. The children can very easily see what 3 multiplied by 10 equals. They can see it in a more pictorial way rather than that abstract, just that calculation of 3 10s is 30. So we use those a lot all throughout the school to aid our problem solving and calculations. This just shows how we've used the part whole model and the bar models to help find missing numbers as well. Often children just cannot see how to work out that missing number. But if they put it into a part whole model, they can then see that one of the parts is 11. 11 plus something, we don't know what this one is, but together they equal 28. So the whole is 28. And the children then can see that the whole take away one of the parts will give us that missing number. So it really does help with that, aiding those missing number calculations that children often find a sticking point in their learning. Okay, this is what our children at the moment in year 2 are moving on to very shortly. Looking again at using that concrete, pictorial and abstract learning to help with column addition. So understanding what this calculation means, rather than it just being a process of answering that, we explore with our 10s and 1s and pictorially on a place value chart, which is what one of these is, how to work out that calculation. So the children will have 5 1s and 7 1s. They will add those up and realise that they've then got 12 1s, and we can't put 12 in our 1s column. So they've got to realise that we can make one group of 10s. They'll actually build these up to make a 10 and exchange that for a stick of 10. So the children can actually see how we work out this calculation, rather than just going, well, 5 and 7 is 12, we put a 2 in there, we put a 1 down here, and then we add that up and we don't forget the 1 on the doorstep. Which might be to somehow, well, that's how the teacher taught us what to do. They're not understanding what that extra 10 down there is and where it's come from. But using the concrete and the pictorial methods, we can show them what that actually means. And that would have been a really good one to use in the classroom. We actually modelled that in the classroom with yourselves as well, but obviously this evening we're a bit more virtual than that. Okay, and likewise, we do the same for column subtraction, the same procedure using that concrete, using those 10s and 1s, using the pictorial picture, the place value chart, and helping the children to understand that difficult concept of 2 take away 8 we can't do. So we cross something out here and we put a 4 and we move it over there and put a 1. Children are flummoxed by that. But when we unpick it alongside manipulatives using those 10s and 1s, the children can see what that means. So when we can't take away 8, well, we can, because we use one of these 10s and the children exchange that for 10 1s. They actually physically swap that in the classroom with the 10s and 1s to show that we've then moved that across, and we'll get 12 1s in here. Okay, so that's just showing you how in everything we learn, we use those 3 concrete onto the pictorial, finally to those abstract written methods, and we use them all alongside each other to deepen that understanding of the mathematics. As I mentioned earlier, there's lots of talking for mathematics. So the children discuss, talk, explain, justify all the reasoning, what they're doing with their maths. So we encourage lots of vocabulary to be used and the correct vocabulary to be used. So this is just an example of alternate words for adding that we might encourage the children to use, taking away, multiplying, and dividing. And the big one in the middle is getting the children to understand what this equal sign means, and that it doesn't just mean, well, the answer is, because that's what flummoxes the children. If we give all our calculations looking the same with that equals on the end, they just think that must be the answer. So then when they come unstuck then is when that equals is in the middle and you've got to balance the equation on each side. So you might have 4 plus 2 equals 6 minus what? And that's where the children have got to understand that that equal sign means the same as both sides of that sign have got to balance. It doesn't mean this is the answer to. So we do lots of talking about that vocabulary to get the children to understand what each of those symbols means. There's a big emphasis on mental strategies now in our learning. So the children using different mental strategies fluently to help them solve calculations. So these are some of the things in year 2 that we try and get the children to become fluent with. So the big one that they should come out with in year 1 is their knowledge of number bonds. And this is paramount to everything that we do in year 2. So it's their number bonds for adding and subtracting up to 20. So that's a huge amount of quick fire calculations that they should know. And it's not just what numbers make 20, but it's quick fire of all those numbers up to 20. So that's a huge amount of knowledge that they've got to try and grasp by the end of year 1, that is. So we still do a lot of work on that in year 2. We then use our related facts to learn our number bonds to 50. So if we know 2 and 3 is 5, we know 20 and 30 is 50. So the children they're quite good at grasping those number bonds to 50 and likewise to 100. Do lots of work on quick fire doubles using our near doubles and halves. So children knowing that double 6 is 12, double 7 is 14, 6 and 7 therefore is 13, because it's 1 less than 7 and 7. So doing lots of talking about their doubles, near doubles, halving. We then move on to multiplication, so counting in 2s, 3s, 5s and 10s. So lots of chanting and knowing their 2s, 3s, 5s and 10 times table. And not just being able to go 2, 4, 6, 8, 10, but knowing that 1's 2 is 2, 2 2's are 4, so actually chanting those. Likewise, the division facts for that as well. So knowing that if 2 6s are 12, then 12 divided by 2 is 6. And then looking at methods for adding 9 and 11 and subtracting 9 and 11. So adding 9 by adding 10 and taking 1 off, rather than children putting the number in the head and adding 9 more on. A quicker method is adding 10 and taking 1 off, so adding 10 and adjusting that number. So we do lots of work in class each week on mental strategies, and the children have now started to bring home a mental strategy that we're working on currently for them to practice at home as well. So here are some of the computer and online games that we have that help the children to become fluent in their mental strategies. So we've got a great one, Hit the Button, which can be access free. So you can just put that into Google and it will come up with Hit the Button. And there's great ways of learning. Their number bonds to 10, 20, 50, 100 are on there. All their doubles, halves. And when we come on to times tables and division facts, the children can learn those as well. So that's a really good, quick, easy one. It can be on your phone, on your iPad, on a laptop that the children can access. 5-10 minutes just practicing those mental strategies. Likewise, they're number bots, which we've got logins for. So each child was given a login at the beginning of the year. So if you've misplaced that or lost it, you can ask for a refresh, and we can send out their number bond login, because that's a number bot login. That's a really good one for practicing those mental strategies as well. They'll all receive a login for Timetable Rockstars as well, which is another online game that we use for multiplication and division facts, becoming fluent in those times tables. And then just lots of other games that we can access free on the top marks. So there's some other mental maths operation games that we can access. Okay. So just recapping how things have changed with our learning over the last couple of years, we have a daily mathematics lesson. So the children every day do mathematics in school. A big emphasis on mental calculation. So before they start their lesson for the day, we have what's called a flashback 4. So that flashes back 4 questions on their prior learning from the lessons before or last week's work. And it's a big emphasis on mental strategies, asking children how they've worked things out and just refreshing them on the learning that they've already done. The lessons are interactive, so lots of concrete learning with apparatus and drawings and finally abstract work, but working as a whole class and group teaching together so the children move through the same learning together. But we deepen the children's knowledge with those problem solving and reasoning questions. So the children actually really enjoy their maths lessons. I can't think of any children that sit there, oh, it's maths. They love it because they're practically working, talking and solving problems together. And ultimately, it's mathematics with understanding. So it's not that, oh, we just do this, this and this because the teacher told us to. They're understanding why they're doing something. And if they don't understand, they're questioned. Through their questioning and their reasoning, they can say, we can unpick those misconceptions if children don't understand what they're doing. Okay, ultimately, we're leading at the end of year 2. The children sit a Key Stage 1 SATs paper. So they actually sit 2 papers at the end of May. There's an arithmetic paper, so that is predominantly using those mental strategies just to complete abstract sums. And then we've got a reasoning paper where the children complete more problem solving and reasoning type questions. We'll go into this a lot more detail when we do the SATs meeting, but there are basically 25 arithmetic questions that the children answer across the 4 basic calculations: addition, subtraction, multiplication and division, and a lot of fractions as well. So we do come on to a big chunk of our learning of fractions. And then they sit a reasoning paper, which is more word problem type questions. And it covers all their learning from year 1 and year 2. But as I say, we'll come into more information about that when we do our SATs meeting, and we can show you what sort of questions they look like. Okay, so that's a whistle-stop tour of year 2 mathematics, how we teach it in class and the expectations. There is a big expectation on the children. It does jump up to lots of working with numbers up to 100 quite quickly, but be reassured that that practical aspect of the learning follows through all the way through the year. So the children are understanding what they are learning through those practical activities. Okay, so if there's any questions, please feel free to ask any questions. If not, I'm going to put this onto the website so you can access it again. It has been recorded for anybody who wants to watch it again or anyone who missed it. And I just ask that there is a text or an email being sent out with a little survey, if you wouldn't mind just feeding back from the meeting this evening. Okay.
Brilliant. That was lovely, Mrs. Ellis. I don't know, Mrs. Collins, did you have something you wanted to ask?
I did. Can you hear me?
Yes.
Oh.
Sorry, I've gone in the dark. I don't think there's any electricity in St. Mary. I'll just pop the lamp on.
Just undo that. Oh, there it is. Yeah, see, got the lighting on. There you go, Evie.
Sorry, they go out automatically.
It's all right. Just these that have been sent home in the book bags.
Yes.
Is this the mental maths?
Yes.
So what, do we need to send these back, or do we just sort of?
No, they're for learning at home. So the
Right.
children can learn this strategy that they're being taught at school. That's just the little slip for them to practice that procedure at home. And then we will do little tests in school just to keep them refreshed on those mental calculations.
Brilliant, thank you.
Okay.
Brilliant. That was lovely. Thank you, Mrs. Ellis. Fabulous job. And we'll put that up onto the website so anyone who wants to rewatch it absolutely can. Okay. So thank you very much. And thank you to everyone for coming as well. Okay. Goodbye.
Okay. Thank you. Bye.